Hey Benji.
Hey Rob, how's things?
Good. How are you?
Yeah, hot.
Same.
All right, what are we doing? Conflict working group. Genders. 2026. It's somehow 2026 already. It's somehow July already. Like this old time just keeps ticking by. So it looks like it's just you and Lee tonight.
Yeah.
I'll go ahead and remove Lee from the thing and have myself instead. Um, all right. You feel free to go ahead and run the meeting if you want.
Yeah. Well, so if you are up for doing some spec review, I have the next one
Ace.
for
Just for the purposes of YouTube, I'll just go through the intro just real quick. So, hey everyone, by being here, we have agreed to the specification membership agreement, the participation guidelines, the contribution guide, and the code of conduct. And we know that the meetings are being recorded, they're published to YouTube, and we use large language models. Tonight, we've got myself, Benji, and Rob on the meeting, and we're going to go straight into the defer and stream spec review. Carry on, Rob.
yeah, thanks for that. So I'm just gonna put the link in the chat. Uh, this is the first time that we are as a group reviewing the execution section, and since it's a big one, I separated out just the collect fields and collect subfields functions, the changes there. Um, in the description of the PR, there's a link to PR 1110, which is the entire changes, but this is just that going into the integration branch.
Perfect. I remember that when we did this, this was one of the places that we introduced the idea of like returning multiple values from a spec algorithm. Have we got
Yes,
any changes like that actually in the main spec now already?
I don't think so.
Okay. Um, so I would like to just run it by Lee at some point just to make sure that the like grammatical structure that we're using there is the right way of doing it. I think it probably is. I think it's probably fine. But I just want to, make it reasonable because no, normally you'd return one value. Returning multiple values is different. Like, should it be wrapped in a tuple? Is it an array? It shouldn't matter from the specs point of view because it's kind of written in language rather than actual code. So I think it's probably fine. But that's one of the more interesting parts of this, I think.
Yeah,
Um,
for sure.
cool. And well done for getting the pull request number 1234 as well.
Oh, nice. Yeah, I'm gonna look through the spec just to see if there is anything else like this.
Cool. I'm just going to
I
start reading through this.
Yeah, and you'll notice this the data structures being used get a little bit more complicated than they were. So there's a whole introductory section before the algorithm begins that defines each one and the fields that are on each data structure.
Yeah,
And
good.
there's more of that more of that to come in the other parts of the section of the execution section.
You've written a field detail is an unordered maps. I assume you mean it's just an unordered map rather than a list of maps.
Yes, that's because yesterday I changed it from plural to singular and missed that.
Ah, okay, but it is a field details is just a single object.
Yeah,
Okay. And then you have a set of those. Yes, okay, that makes sense. Cool.
I'll push that up right now. That fixed.
I've read your definition of defer usage. I don't fully understand what a defer usage is.
What I'm trying to say is that we need to pull out of collect fields where the defers are. And I'm trying to say that it's not exactly one-to-one with the defer directive that's in the document because it could be used inside a list field. And this is like the defer as it applies to the result. So one defer directive inside a list field will be and defer usages for each item inside the list.
Okay, yes, that's what I was looking to understand. Okay, cool. So if there were no lists, then even in nested selection sets, there would only be one defer usage for each defer directive. But once you mix lists into it, their defer usages will multiply up.
Right.
Okay. We use a usage term already. Is that directive? No, variable usage. What is it? I can't remember. Yeah, variable usage. So variable usage would not do that, even though obviously those can occur within lists as well. So yeah, we do need a clarification there to make it obvious. Um, Interesting. All right. I'll keep reading anyway, whilst my subconscious ponders that. Okay, I hear what you said, but also you say in here a single defer usage may be used to create many concrete delivery groups when a defer is included within a list type. So does that mean that a defer usage is document level and the delivery groups are the one that multiplies up?
Let me take a closer look. I think I got that wrong in my when I explained it previously. You're right. This is right, that the delivery groups are the ones that multiply out. The defer usage is the defer, I think it's the nearest defer that follows the field up to the fragment. So as
Yes.
we're traversing down, we're taking that defer usage and we are passing it to all of the selection and selections of selections inside the fragment until we get to another one where then it gets replaced by the lower defer.
Mhm. So it is much more aligned with a variable usage. It's like
Yeah,
it's a document level thing rather than a runtime thing.
yes. And the
Okay.
delivery groups are the runtime ones.
Okay, this is really good news because it means that the usage verb is the usage is aligned with our existing use of that same word. So that's really good. Um, cool. I will try and help clarify the wording around that. Um, really good. So then it says that the field detail, sorry, alarm's going off. Um, it says that the field detail contains the defer usage and the field. I just want to confirm that that is correct. So it contains the reference to this single defer that would be shared across all items of the list, rather than it being. I was kind of expecting it to be the execution group, I think. But no, it's done during field collection, isn't it? So of course it can't be the execution group because it doesn't exist yet. No,
Right.
wait, does it? It doesn't during validation, but this is execution. So yeah, it would exist at this point. Yeah, so isn't it the parent execution group that we would care about here? It might become clearer to me once I read the rest of the algorithm. So you can just tell me to read the rest if you want.
The defer usages, I believe, get turned into the execution groups later on after this happens.
Okay,
And
cool.
it's probably not in this PR, but it's in, I think it's in another function.
But this, as it's currently written, this mirrors how GraphQL JS works currently.
Yes.
Okay, cool. Okay, so this algorithm is effectively this is collect fields and it is going through and it's figuring out um to use a kind of a phrase that I was using back when I was thinking about this, a couple of years ago. It's essentially coloring the field selections. So it's going, these ones are all green because they're in the same level. These ones we're going to color red because they have gone through a defer. These ones orange because maybe they've gone through two defers at this point, whatever. And it's essentially coloring them. And then something else later is going to be responsible for then taking that coloration and going, oh, I don't care that this one was colored red because there's an identical one that's colored green, and that one wins essentially. And that's when it gets turned into an execution group, which is why it makes sense. That you don't need to have understood what I just said there. That was mostly for myself. Um, yeah, okay, cool. I think I get it. This is good. Minor minor question. Would it be correct to say that a defer usage represents the usage of a defer directive within a given document? You've put operation currently, but I'm thinking that actually document is accurate unless when you compose fragments, they produce different defer usages. If the same fragment is used across multiple operations, for example.
I think it doesn't matter because you would only be executing
A single
one
op.
operation
Yeah.
and they're getting created from scratch.
Yeah, you're right. There's not much there. I'm just trying to think of like when you're composing fragments together, um, do they produce different defer usages depending on how you got to it? Like if one is nested within um like a deep selection set and one of them's like at the root level selection set, not root but like one level down. So like if you have a fragment on user and that has a defer directive in it, um and you call that on current user but you also call it on like all posts, post authors, and then there, are they the same defer usage because they would be the same variable usage if it was a variable, right? Are they the same defer usage or are they different ones? Because they're different, aren't they? Because the nested one might be inside of another defer.
Yes, they are different
They are different. Okay, so they
because the
are
defer usage, it's not just the defer directive, it's also the
the
parent
path.
defers.
Yeah. Okay, cool. That clarifies further as well. Thank you.
Yeah, and sorry, this was written a long time ago, so I'm still a little rusty on it too. I remember now when we were working on this, we went through a lot of effort to not include path in the arguments of collect fields because that would mean that it can't be memoized across list across list items.
Yeah, that's really smart.
So that's why there's that's a big part of why there's the whole abstract defer usage that gets returned out of here, and then the execution groups are built separately.
Yeah, that makes a lot of sense. Um, how so in GraphQL JS terms, how do you when you're doing collect fields, you would see a field and you would see that it has a defer um, directive. No, sorry, that's not how it works because defer applies to fragments. So you would be doing value completion on a field, and when you do that, you're resolving fragments. And when you do that fragment, you would then see a defer there. Uh, I'm going to stop thinking out loud and just think in my head for a moment.
I think the answer is that the defer usages are since they're returned on the field details, and that gets passed through the whole algorithm, so that if you when you do call collect fields on a on a selection set, the one from the parent fragment gets passed down to the next level until collect fields goes and finds another one that will replace it in the case of nested defers.
Right, but if you're completing a list field and the list field, so you're inside of a defer, let's call it red. You're inside of defer red, and you're now completing a list field because you're executing. You've already deferred execution. You've got to this point. You're now doing the execution there. And this list field returns 10 items and it has a selection set which has a child defer in it. Um, that defer usage for each of those 10 items, let's call it defer green, that one wants to be the same one, right? It wants to be the same green for all of them. Wait, I can't remember how list execution even works. I'm going to read through the list execution algorithm in the spec. Just give me a sec. Value completion, complete value, just list type. Channel list where each is the result calling complete value. Right. So in the current spec, as it currently stands, the complete value algorithm goes through if your field is returning a list, it will just execute, it will complete value for each of the items in that list, which means it will currently do collect subfields for each of the items in that list. But this is where you've solved it in GraphQL JS. In GraphQL JS, that is memoized. So long as it sees the same parent defer usage, any child, because it's only going to collect the subfields once, um, any child one is going to be the same. And then you go and execute them, and that's where those multiply up. But okay, yeah, I get it. It's the memoization that does it. It's not the spec doesn't do it, and the spec doesn't care. But GraphQL JS does it as an optimization. That's actually really interesting and a little bit subtle, and also
Let me make
relevant
sure
to the.
I understand what you're saying. When you have that list field and there's a defer inside of it, and we have we've called collect fields each time, and each field has. We're not going back and saying that they're all the same and they get grouped into the same execution result. They are separate. Even though collect fields was memoized, we're looking at each one individually when they get executed.
Yeah,
And they're
you're thinking about the execution groups, but we're not at that part yet.
yeah,
So I'm just thinking of the defer usages. So with the spec as it currently stands, when you complete a list value, each of those list items will be processed individually, right? And so each one of them will call collect subfields, which will then use this new algorithm, presumably because collect subfields calls into collect fields. Does it? No. Yes. So collect subfields calls into collect fields. So every time we see those fragment spreads with a defer on, we will see that new defer and we'll create a defer usage for it, which has a parent, which is red that we saw before. But for the first list item, we'll create a new one, green. And for the second list item, we'll create a new one, blue, because we don't know about green in the second one. We have no clue that green even
right.
existed.
Yes.
So we'll create blue and then purple and whatever. And then if you then extend that to further down the execution algorithm, now every child of that, green has its own children and blue has its own children. And suddenly you've got this multiplying out, this fanning out behavior. But in GraphQL.js, you don't have that. In GraphQL.js, the first field does that field collection and it makes green. And the second, sorry, I said field, I meant list item. So the first list item makes green. And the second list item doesn't even bother to do collect subfields again. It's just like, oh, it's going to be the same subfields as that other one that we just did. So it doesn't create anything. It just reuses green. And because that green gets reused, that can be reused throughout the whole, like each next level will do it. So the spec kind of states that it will fan out. GraphQL.js doesn't do the fanning out because it does memorization, but that's okay because the spec doesn't actually require you to fan out. It just requires that a user who looks at it can't tell the difference. And you wouldn't be able to tell the difference because it's not observable.
If you did a so list item one, list item two, if you looked at their defer usage, the new ones in GraphQL.js, I think if you did a strict equality check, it would be true because
Yes,
it was memoized.
because it
That
was
that doesn't
memorized.
matter to the algorithm. It still fans out into different execution groups.
Yes. But also in the algorithm, in the spec, it will also fan out the defer usages. So we can't say, for example, that there is one defer usage per like position in the document because that's not true. It's true for GraphQL.js purely because it does memorization, but for the spec, it's not true unless we mandate memorization of collect subfields, which maybe we should because that's an expensive algorithm and that's the reason that GraphQL.js memorizes it. But without that statement that it should be memorized, it will not be the case that there will be only one defer usage in the spec.
Yes.
Anyway, this is mostly relevant to me because I was trying to rewrite the wording of what a defer usage is. And I was like, oh, there's exactly one in each position in the document. No, wait, that's not right. Oh, there's exactly one per path. But that's correct for GraphQL.js, but not correct for the spec. So I'm just going to revisit it a third time now that I've got a better handle on how this works.
Yes. The paragraph that describes defer usage now is clumsy and I don't think it's 100% accurate. So we should definitely rewrite that. Yeah. Agreed.
Okay, I think that what's happened here is too much of the way that GraphQL JS works has been kind of like incorporated into this spec wording. And now that I've sort of broken it down and understood exactly what's going on and what it means for GraphQL JS and what it means for the spec, which is two different things, I think actually that intro paragraph is much simpler. I think it's literally a defer usage is an unordered map representing the usage of a defer directive during collection. It contains the following information: a label and a parent defer usage. Um, do you actually reference the fact that it's an unordered map elsewhere? Do you like extract a key from that map explicitly?
I'm not sure.
The
You mean the
reason
fact that it's ordered or unordered?
No, it's just the reason it's the fact that it's a map at all. Like, I don't think it matters. I think you just use whatever it is. You just a defer usage is the label and the parent defer usage. Store it how you want. Um, if you look at the very beginning of chapter 6, a GraphQL service generates a response from a request via execution. A request for execution consists of a few pieces of information: schema, document, operation name, variable values, initial value, extensions. It doesn't say that a request is an, I don't think it does anywhere. It doesn't say that a request is an unordered map of those keys or anything like that. It just says it has that information. And I think the same is true of a defer usage. How you store it internally in GraphQL JS, in GraphFast, in Hot Chocolate, in wherever, literally doesn't matter. Like, so long as you can extract those concepts from it, so long as you can get the label from the defer usage and get the parent defer usage from it, it can be a tuple. That's fine. It can be a unordered map. It can be an ordered map. It can be whatever you want. Doesn't matter.
Let me check in the rest of the spec how we use it. So we'll say stuff like let parent defer usage and label be the corresponding entries on defer usage, and then do stuff with those separately.
Yeah, so I think in those cases you can just say let label be the label of the defer usage. And you don't have to say it's like the entry within the map or anything like that. Um, because it doesn't matter. Um,
This is most likely just that I wanted to say it's an object with these, and just because I wanted something to hold it, and we don't use object, we use map for most things, so that's what I did.
yeah,
Like,
no, no,
yeah,
no, I get it. I'm just trying to simplify exactly what the requirements of the algorithm are, and the actual
yeah,
data structure that you choose for this isn't specific. Whereas for like field collection, like it, you do need to know that, or field execution, right? You are building an ordered map. That's significant. When you process various other things, the actual data structure you use is a significant thing that has observable effects on the result. But for this
yeah, because
one,
we're setting dynamic keys in that, but that's not the case here, and we could probably do the same thing with some of the other data structures.
yeah, I think we probably should. And in general, it gives implementers more choice. And also just like simplifies the language as well, because you don't need to say unordered map and then people have to think about that. You just say like it's got this stuff in it.
Yep, sounds good.
Cool. The field detail definition doesn't actually contain a definition of what a field detail is. It states what it contains, but it doesn't like describe it in words or describe what its meaning is. Like, why does it exist?
Yeah,
Like, it's not a good glossary entry, if you see what I mean.
yeah, I see. Are you leaving comments for these things, or I could take notes either way. It's fine.
Where I am, I'm doing them as live comments, so you'll see them immediately. Well, I'm posting them. I'm not putting them
Okay, okay.
in a review.
Yeah, no,
Just
no, that's
posting
fine.
them
I just
directly.
want to make sure that I don't forget about them.
Yeah, I'll toss this one to you. I'll just add needs a more descriptive definition. In general, you shouldn't have like otherwise undefined. Like undefined is a JavaScriptism.
Yeah.
Also, like there's no reason that defer usage couldn't be null, or any other choice that the person has. So I'm just going to trim it down to just if any.
Okay.
Um, I'm just going to refresh so I can reference the correct line numbers. Okay, you've kind of broken the structure of algorithms in the spec. So lines 442 and 43 define the entry point to the algorithm, which should then be followed by algorithmic steps. But what you're then doing is describing more stuff about it. So I think just literally 442 and 443 should move all the way down to just above line 479.
Okay.
I don't think this is harmful, but I don't think we normally add a block that like describes the return of a of an algorithm. Like it's normally just left to be self-evident. And like collected fields map is the collected fields map for the fields in the selection set is kind of redundant. I understand that the new defer usages is a little bit more meaningful. But I think I would be tempted to just delete that entire
I think I was thinking because it is a
because it
something that
returns multiple
returns.
values.
Yeah.
Yeah. I understand the initiative for doing that, but I don't think it's necessary.
Yeah, sounds good.
I'm trying to determine, so I'm looking at how collect subfields and collect fields interact with each other, especially in regards to how the defer usages are created. Um, so what I'm thinking is if you reference the same field twice with essentially the same selection set, but obviously in AST terms, they're two different objects. So I've just put into chat field A with a selection set, which is a fragment, which is deferred, and field A again with a selection set, which is a fragment, which is deferred, a spread of a named fragment. Um, those two defers there, they will get different uh, defer usages. One will be red, one will be green. Um, no matter whether this is done through the spec algorithm or the GraphQL Jet algorithm, I don't think the memoization saves us here because technically those two selection sets are different selection sets in memory, so the memorization won't kick in, I think. Um, my question is, does that matter?
I think what happens is so when you do the top selection set, you do get two field details, right? There's no
Yeah.
defers on either of them yet. Then when you do uh the selection set of that, um it does iterate through both, right? But there is, I know there's like the visited fragments. Okay, so this is different now.
Yeah, yeah. You keep talking about the previous one because the other one is just, the flip side of it. Visited fragments pops though, so like each visit to frag in that position wouldn't prevent the second visit to frag, I think,
I
because
I don't remember what happens. I have to
yeah,
sit with this a little bit.
if you had like employer and that had frag and you had employee with frag, those would those would need to have different visits. So I don't think that it I don't think that it remembers, but maybe it does because they get grouped. So maybe yeah. Fun. Yeah, maybe
When you
they
say
do.
employer employee, are those aliases?
No,
Or
just assuming that they're both fields that return user. But yeah, those wouldn't have been grouped together. So yeah, maybe I can't. I think it does do it because I think there was actually an issue that was caused by that. It had to do with the way that like errors were handled or something. No, I don't remember specifically. Anyway, whatever. That's by the by. They'll end up with different colors, red and green, and I don't think that matters. I think it's fine. It's just a curiosity. Um, I really like the note that's been added after collect fields. I don't think that it's strong enough. It's a note, so it's non-normative anyway. And it says GraphQL services may choose to memorize their implementation of collect fields. Um, may is technically like an RFC 2119 word. Um, and it's accurate. They may choose to do this. I think it's different from that. I think we would recommend that you do that. And in fact, I think it would be, you will often have catastrophic performance and memory consumption issues if you don't do that. Um, so I think I would use the word, uh, I think we should say they should, even though it's non-normative. And so the should actually holds no weight. I think it still passes more of the intent to the implementer. Like really, you should be like you. We're not going to dismiss you as an. We're not going to test you against it to find out whether you memorize or not. But really, you should be memorizing this. Like you're going to have a bad day if you don't.
okay, yeah.
And I'd also like to maybe contain a lit. I'm not adding notes on this, by the way. Um, I think maybe it would be valuable to also add in there like the significance of doing so with regard to the defer usages. So if you memorize this, then it also means that the number of defer usages will not multiply up in the same way, which is really valuable.
Okay,
Yeah, I think
yeah.
I think just in general, I would make this note a lot more compelling. I would say GraphQL services should memorize their implementation of collect fields in order to um, prevent non-linear memory consumption or something like that, or superlinear.
Okay, yeah. I'll think about it.
Something like that. I'm going to leave the general tidying of like you've done, let field details be a new unordered map containing field and defer usage, but like the simplification of that down to new wording that doesn't rely on it being a map, I think I can leave to you. It's just going to be a slight simplification. Um,
Did you leave a comment about changing it to not be a map?
it's kind of covered by my initial simplification of the definition of defer usage.
Okay.
It just says a defer usage represents the usage of a defer directive during field collection. It contains the following information. And that's it. It doesn't say what the data structure is. That's the only note I have on it. So the rest of it you'll have to like carry through. For each of the selections in selection set, if the selection is a fragment spread, if the selection provides the directive defer, and its if argument is not false and is not a variable with the value false, null. Yeah, okay. Then let defer directive be that directive. If the execution is for subscription, raise an execution error. Okay. This is one of those things where depending on what programming language you essentially translated this algorithm to, the outcome would be different. So if you were writing this algorithm in like ES3 in ancient JavaScript, right, you would follow the if statement on line 506, and on 509 you would do var defer directive equals blah, right? And then on line 514 you'd say if the defer directive is not defined, do the thing, right? But then in your next run through the loop on line 482, that var would still exist because vars are defined at function level and they get hoisted for you automatically because JavaScript's weird. And so next time, if there was no defer directive, your value that you compared in the defer directive on line 514 would still exist and it would do weird things because JavaScript is
Yeah.
weird.
Yep.
So I feel like, and this might be a problem in the broader GraphQL spec as well. So this is another case of like, I don't care if we already have this problem in the spec. I just don't want to make it worse. I feel like it might be better to kind of invert the definition so that let defer directive is like a statement within that if that always executes. Like let defer directive be null. If selection provides the directive, then let defer directive be that directive, for example. Or otherwise, that's what you need. You just need an otherwise. Otherwise, let defer directive be null. Yeah, I think that would solve it.
Okay. Are you leaving that comment or I'll
I
do it?
just have, yes.
Okay.
I don't know if I got the indentation right.
Yeah, that's fine. Thank you.
And then you obviously need to change the later line to if defer directive is not null.
Yeah.
Let fragment collected fields map. Fragment collected fields map. Yeah, yeah. And fragment new deferred usages be the result of calling fragment selection set. Variable value is fragments, fragment deferred usage. Oh, interesting. How does this interact with her? Just fragments wise. Yeah, so I think the whole way that we handle visited fragments in the spec in general is kind of wrong and weird. This is what I was kind of hinting at in my weird ramble that I did just now. Um, Essentially, it depends what programming language you translate the spec to. If it's a programming language that does pass by value, then it's fine. Like when you call into a child, you get a copy of visited fragments, and then you can mutate that copy without influencing your caller. But if you're doing pass by reference, then when your child adds a fragment to visited fragments, you are also impacted by that, which you don't want. I don't think that's your problem, though. I think that's just a problem in the spec in general. I'm just trying to work out whether anything to do with.
Yeah, I think that that's already how visited fragments works in here.
Yes.
It's
Yeah,
not a new
yeah,
thing
it
that I've
is.
introduced.
No, but you are changing slightly how it works. So if the defer directive is not defined, then you add it. But if it is defined, then you don't add it, which makes sense because you're not visiting it, right? Yeah. If the defer directive is defined, then do some stuff. Where's the collect fields? No, you are still calling collect fields. Okay, I need to think through this a bit better. If the selection sets a fragment spread, if it provides the defer, then that's going to be the defer directive. If the defer directive is not defined, then add it to visited fragments. So if it is deferred, don't add it to visited fragments. Then let fragment defer usage be either the relevant defer directive or the parent one. Then go ahead and call collect fields. passing in the list of visited fragments, which, if you've not deferred, does contain the new fragment. And if you have deferred, it doesn't. But you still visit it. Visited fragments serves two purposes, I think, in the GraphQL spec. One purpose is to prevent infinite loops, even in the case that validation was skipped.
Yes.
And the other one I forget, and it's late and I'm too warm to think about it. Are you bypassing that protection by not adding it to visited fragments? Why does that if on line 514 exist?
Yeah, so let's say that the same fragment is there twice. One is deferred and one is not. If the first one is deferred, then we set up those fields, get ready to defer them. Then we come in across the second one and it's not deferred, but it was in the visited fragments, then those fields would get skipped and they wouldn't be in the initial result.
Yeah. So this is exactly what I was saying before about the way that the spec handles visited fragments is like just completely wrong. Or like not wrong so much as like really, really ill-defined. And you have to kind of interpret it in the way that makes sense so that the algorithm actually does the right thing. Um, I don't like that. Like it should be more explicit. So for everything else, for the spec as it existed in 2015, it was kind of the right decision because it didn't matter, right? If you skipped it, then you just wouldn't get that far, right? Because your skip gets excluded above, right? Yeah. So your skip gets excluded on line 483 and your include gets skipped on line 488. So skip and include were completely ignored. And then other than that, fragment spreads were the same thing. So adding to the list of visited fragments is perfectly fine. Again, without the children issue, because that would prevent you from visiting it in another. I remind myself the algorithm arguments.
I'm looking at GraphQL.js and it looks like this is not up to date anymore. It looks like we changed how this works.
That wouldn't be surprising to me in the least.
Yeah.
But yeah, basically, I think I raised a pull request maybe like 3-4 years ago that essentially changed the way that that visited fragments works. I think it essentially just popped. So it added to visited fragments, did the thing, and then it popped it back off the top again to make sure that it wasn't like changed for any future loop. And I think it got essentially rejected because it was an optimization, like it was doing, as as Claude would say, it's doing real work, it's load bearing. But yeah, let me just see if I can track that one down. But I think once it comes to stream and defer, it gets more complex because you have made it so if you skip validation, this is now vulnerable to like an infinite recursion bug through a deferred fragment spread. And there's no need for that. Like everything else here does like fragment X, fragment new defer usages, fragment field set, fragment collected fields map. And you could again have fragment visited fragments, right? Which is just the parent visited fragments plus this specific fragment. And then when you go in the next loop item, you would revisit, like you wouldn't have that value wouldn't have been mutated. But that's kind of the issue, right? That's still the issue.
Take a look at the link I just put in the chat over here.
Thanks.
So I think what this is doing is it's basically like, it's not adding it if it's deferred to visited fragments, but then if it does find it deferred a second time, is that right? That it does add it, or so it makes sure that it solves the that it's not possible for there to be infinite loop.
Let me read a slightly larger context. If we go into a fragment spread, get the fragment name, check that you should include it, make sure that the type condition matches, get the defer usage, get the visited fragment names for that, and that is a Boolean, right? That's a Boolean. There you go.
Yeah.
So that Boolean is either, or that value is either true or false or undefined in JavaScript. So undefined means we've never visited it. The value on line 294 for visited as deferred, it's going to be either true if you visited it as a deferred thing, false if you've visited it at all, I'm assuming, and undefined if you've never visited it. It's the undefined. It's basically it's a trinary. It's a really subtle trinary, I think. Yeah, there's the comment. If this spread is not deferred, it may be skipped when already visited as a non-deferred spread. If it was previously visited as a deferred spread, it must be revisited. Yes.
Yep.
So visited as deferred becomes true, which basically is the light version of yes, I visited it, but I've not really done much with it. So that is explicitly protecting against this issue that I was saying about. But it's doing it in a JavaScript optimized way that would be disgusting to put into the spec. So I think in the spec, we would do it slightly differently. What would we do? So visited fragments is a set that says whether or not we visited or not. What Yakov, I assume, has done, maybe it wasn't Yakov. I'm assuming it was, though.
Yeah, I think it was. Yeah, so he had changed it to a map.
So he's changed it to a map so that he can give it a non-binary, non-Boolean value, right? So previously it was either in the set or not in the set, but actually we want to know one of three things. Have we never visited it? Have we visited it but it was deferred, or have we visited it but it was not deferred? And if we visited it previously but it was deferred, and then we later visit it and it's not deferred, oh, we still need to visit it again now when we need to do it with a stronger visit to it, which is actually quite significant. So it kind of means that visited fragments is either no longer quite the right thing, or we need a secondary set, which maybe is local to this. I think I'm right in thinking. Maybe I'm not. let me just check my assumptions.
I mean, should I make it in the spec to something like this?
Say again, sorry. Oh,
In the chat.
yes, sorry. Yeah, yeah. Um, yeah. I mean, we can. We can. That I mean, that would essentially mirror what GraphQL JS is doing, but it is still a bit weird. I'm also trying to think about how it works with the going through the stacks and trying to realize whether or not collect fields does pass by reference. It doesn't matter. So you're visiting a bunch of field selection sets, and some of them are deferred and some of them are not, and they might have nested fragments, named fragments inside of them. When you visit one of them, if it's deferred, you will need to visit it again if it's non-deferred. But does the path through which you visit it, does the list of intermediate fragments matter? It's like defer, undefer, defer. It would be deferred. Oh, it's complex, isn't it? See, the 2015 version of the spec didn't have to worry about this at all because, like, effectively all these fragment spreads kind of like collapse and go away. They just sort of don't exist at the end of this, really. And it's as
Yeah.
if all of those fields had just been in line together. So it can get away with visited fragments just being one value that's shared across the entire thing. It doesn't matter whether you've nested it 3 levels deep through fragment spreads in multiple locations. It just doesn't matter because it just sort of goes away. The problem goes away. But once you start adding, and it goes away because the skip and include are calculated right up the top. But because the defer has to be evaluated later, and because the defer changes the result, right? Previously, you were just collecting the fields and they're just fields. That's it. But now you're building field detail, and field detail have more stuff in them, and that stuff is going to change depending on which path you go through. And suddenly it's more significant, and I'm not sure whether we can use the existing, like, have you visited it or not. I'm assuming, though, that Yakov has already solved this because it already passes all the tests in GraphQL JS, and that solution is the one that you've highlighted. So I would like Yakov to confirm that essentially once we've rewritten this to do the trinary thing, that it does follow the same algorithm. And if so, then I'll trust that that's accurate. Because yeah, at the moment, this, as you say, it doesn't follow what we do in GraphQL JS because it doesn't do this trinary thing. I really don't like the idea. I really don't like this though. It's kind of ugly.
Yeah,
It's
it
like,
is.
oh, go and read this value from a map. And then if it's got one particular value, then just overwrite it. Yeah, just overwrite it with a new value now. It's kind of it's kind of gross. I don't think we really do overwriting in the GraphQL spec, even in the case of like error propagation. We don't write a result and then overwrite it with null. Like the result just never gets returned in the first place because the exception kind of well, I mean, it's an exception, follows a different path. It like kind of undoes rather than overwrites, if you see what I mean. Um, I don't think we have anywhere in the spec that overwrites a value that writes to the same position twice. This would be the introduction of that, and it's kind of unpleasant. Nonetheless, it is what GraphQL JS does. I suggest that at least for now, you just write up what the GraphQL JS algorithm does in this with regard to visiting
Yeah.
fragments.
Thinking of quick alternatives, they both seem less ugly to me, which is pass two sets around through collect fields, adding another argument where it already has like a lot of arguments. Or having a map of two sets. Both of those seem more ugly than this.
I 100% agree. The
So
management of that is kind of weird, right?
yeah,
Yeah. And like either choosing which of the sets you insert it into, and also like you would need to potentially remove it from one set and add it to another one, which gives you the same issue of like writing twice kind of thing. Removing is a write. It's kind of an overwrite almost. Yeah, I agree. Just write up what's in GraphQL JS and we'll suck it up. It's fine. Yeah, other than that, I think it's in pretty good shape. So basically, tidy up a few of the definitions, move the algorithm um, definition header downwards, um, make sure that the visited fragments mirrors what is done in GraphQL JS. But generally, oh wait, I've come full circle. I've just realized. Because defer usages do fan out in spec terms, I wonder whether it might be worth coming up with a different name to usage. Because again, like a variable usage occurs in one position in the document. It's just a usage within the document. A defer usage it's okay, it's in the execution section. So it's a usage during execution. That's fine. I think that's fine.
great.
Do you refer to defer usage anywhere outside of section 6?
No.
Then I think it's fine. Yeah, a usage during the execution chapter makes sense that it would be a usage during execution. Um,
Yeah, we reviewed all the other sections other than section 6 now.
Perfect. Yeah. Okay, cool. So just a little bit of the tidying of the algorithm. I think you don't have to remove the data structures. Like you don't have to if you don't want to. Um, I think I would just purely because I think it makes it simpler and gives the implementer more choice. But if it ends up actually making it more complex, makes the wording more ambiguous, then just roll it back and stick with what you've currently got. It's not bad. I just feel like it could be simpler.
Yeah,
And yeah,
I'll see how it goes.
thank you for doing all of this. This is, it's a complex algorithm.
Yeah,
All of
thanks for
this
your
work is
time.
complex.
Thanks for your time reviewing. I'll work on this. I'll post in the Discord channel when I've made all the changes. And if you happen to have time to look at it again, great. If not, then I'll see you at the next secondary in August.
Okay, cool. I might not be at that one, and I also might not be at the primary because August is like summer holidays for the kids, so we might be away. I don't know, we haven't got firm plans, but we
Okay.
do things last minute. But
Yeah.
yeah, just FYI.
Okay. Well, whenever we'll get back to this soon enough.
Cool. All
All right.
right.
Thanks so much.
Cheers, Rob.
Bye.
Bye.